Okay, in today's video we're going to be looking at what is called non-standard partitioning. So partitioning is just taking a number and representing it however that number is built. So let's say our number was 1,423. We'd represent that number as 1,000, 400s, 2 10s, and 3 1s. If we wanted to take that number and then put it into non-standard partitioning, to do that, all we would need to do is to regroup. And when we talk about regrouping, we talk about just changing the way that a place value is represented. So that could mean taking 100 and representing it here in the tens place. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The value of this number has not changed. I still have 1,000. I still have 300s. But that fourth hundred is now represented as tens. But that still equals the same thing. I can prove that simply by doing 1,000 plus 300 plus 10, 20 plus 10 tens is 120. And then 3 1s. If I add all of that together, I'm still going to have a 3 in the ones place, a 2 in the tens place, a 4 in the hundreds place, and a 1 in the thousands place. It is still the same number. Let's take a look at another way that we could use non-standard partitioning on this same number. So let's partition it in a standard way, which is 1,000, 400s, 2 10s, and 1, 2, 3 1s. Now, what if I wanted to do all sorts of things? Let's take 200s, and we're going to regroup both of those. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So both of those hundreds are now represented as tens. What about taking this? Let's take this 10 and let's make it into ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's still non-standard partitioning. The value of this number has not changed. I'm just representing it in a different way. It's the same idea as if you had, let's get a new piece of paper out here before I go through that. It's the same thing as just finding new equivalent ways of representing a number. So let's say you have a $10 bill, and your friend has a $5 bill and a $5 bill. Both friends have the same amount of money. One has 10 as a $10 bill, and the other has 10 as 2 5s. What about another friend who has a $1 bill, 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 and then a $5 bill? This friend has the same amount as this friend, who has the same amount as this friend, but they're all represented in different ways. Non-standard partitioning is just that. It's just taking a number, representing it in its standard form, and the standard partitioning. This is standard form, this is standard partitioning. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. All right, 498. We want to show our partitioning. We just regroup. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we would say that this number is made up of 300s, 19 10s, and 8 1s. The non-standard for partitioning. Standard form, non-standard partitioning, and then written as non-standard partitioning. this ends up showing up as a lot of different things. There are a lot of story problems that might involve someone saying that someone went to the bank and they deposited 25 $1 bills. They also went to the bank and they deposited 36 $100 bills, 17 $10 bills. Okay, and just be aware I'm about to go into nonsensical amounts of money, but this is purely just as a way to give scholars another way of exposure with these partitions. So I might even say to a scholar that there was 21 $10,000 bills. I know that that's not a thing, but we go with it just for the sake of our stories. Just like the farmer who goes and buys like 3,000 watermelons at Stop and Shop. It doesn't actually make any sense. We just kind of go with it because it's what's making our maths make sense. All right, let's do one more place value. Let's say then $74,000 bills. We'll just go with that for now. Okay, so let's say that a scholar is posed with this problem. If they were given this problem, they would need to first start out with a place value chart. So I would say 100,000s, 10,000s, thousands, hundreds, tens, ones. I think showing this on a place value chart is the easiest way. It also helps scholars really just show the regrouping pretty quickly. All right, now I'm just going to take each of these values and place them in the place value chart as if the place value chart represented the dollar bills. So this says 25 $1 bills, so I'm going to pretend like that's 25 ones, and I'm going to put 25 here in the ones place. Then I see 36 $100 bills, so I'm going to take 36 and I'm going to put it in the hundreds place. I see 17 $10 bills, so I'm going to put it in the tens place. 21 $10,000 bills goes in the 10,000s place. And then $74,000 bills goes here. All right. And then it's just a matter of regrouping, right? We know all of the values are based on a base 10 system, so we can show this regrouping pretty quickly. We're just going to take this 2 here, which actually represents 21s. 21s is the same as 2 10s. So I'm going to move that over here as 2 10s. That means the 17 is now, in fact, a 19. A lot of scholars will get mixed up here and want to put that it is 37, but remember that these 21s actually only equal 2 10s. If I drew that out, if I put it up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5. All right, so here are 25 ones that are currently in the ones place. That's 1 10. That's another 10. So that's 2 10s that are going to move into the tens place. But right here, these 5 ones, they're actually going to remain in the ones place. So I'm moving 2 10s, which is 21s, into the tens place, leaving behind 5 ones. Now I have 19 10s. Well, 10 10s is equal to 100, so I take 10 10s, and I move it over here. So now instead of having 36 hundreds, I have 37 hundreds. I do the same thing. 10 hundreds is equal to 1,000. So 30 hundreds is equal to 3,000s. And you just follow that same process each time. So this 74 becomes 77. All right, so 10 thousands is equal to 1 10,000. So 70 thousands is equal to 7 10,000s. Move this over here. This 21 becomes 28. All right, and then 10 10,000s is equal to 1 100,000. So I take 20 10,000s, and that equals 200,000s. That's here. And so now I'm going to take this number from non-standard partitioning and move it into standard partitioning by rewriting this number as its new value with all of the regrouping. So there's a 2 left here, so it's a 2 here. There's an 8 here, so it's an 8 in the 10,000s place. There's a 7, so there's a 7, we'll put it over here. There's a 7 here, 7. There's a 9, and a 5, and a 5. So that means that in this nonsensical story problem that I just made up off the top of my head, that whoever it was went to the bank and they deposited $287,795. So when we think about non-standard partitioning, we think about it in a variety of different ways. We think about it in the ways that numbers can be broken up into its various base 10 properties. or values. So in this case, we used fake money amounts, and we talked about how all of those things could be deposited, and then we could find out the grand total of money that was deposited in. There we go. Sorry, that was cut off. We looked at how a basic number can be rewritten using its place value blocks and then shown its values. So this was the 300s, the 1910s, and the 81s. The real life example of actual money amounts and how numbers can be represented different ways. They're all $10, but this is 10. This is 2 5s. We had 5 1s and a 5. And then back to our original model here with the non-standard partitioning, and that was us taking the number 1,423, splitting it into its place value blocks, and then simply just moving place values around using the process of regrouping. As usual, if you have any questions, please feel free to email or call, but this is non-standard partitioning in a few of its different forms.